So, good day everyone and welcome back to our YouTube sessions. And today we have a topic on the board. We are going to talk about what are called organic reactions. And so we want to understand organic reactions. We have different organic reactions that range from combustion reaction, oxidation, that range from addition reactions, substitution reactions, esterifications. All those ones are organic reactions. So organic reactions, these are reactions in which organic molecules they go through. So we want to focus today on what are called oxidation or combustion reaction. So let's speak to those ones who are joining us today, and if it's your first time, make sure that on your way out, just click subscription button and notification button so that next time we post more content, you will be notified of more videos that we shall post from time to time. So for now, let's get into the reactions. So combustion reactions, just to understand them, these are reactions of alkanes. So alkanes, what happens to alkanes? Alkanes, they react with oxygen. After reacting with oxygen, we have two standard products that we get when those two react. The first one is we get carbon dioxide, and we also get what is called a water molecule. But at the end of reaction, these are exothermic reactions, so we will also get what is called energy when those reactions are completed or during reaction. So what we need to understand now is that when alkanes burn in air, when they burn in air or when they burn in excess of oxygen, what happens? So let us have an example here of butane. When butane burns in air, let us understand when butane burns in air, what are the products, and what is most important today is we want to understand how do we balance oxidation reactions. So butane, the structural formula, the molecular formula of butane, we have C4H10. It reacts with oxygen, and we have carbon dioxide and our H2O as the products. So what is going to happen next is that we want to balance these molecules on the left hand side and molecules on the right hand side. How do we balance them? First and foremost, you must introduce a 2 on your alkane. Introducing a 2 on the alkane, it means we're going to have a 2C4H10 plus O2 and carbon dioxide plus water molecule. After a 2 is introduced, now the first molecule, the first atom that we should balance in this equation is our carbon. So carbons on the left hand side are more. Let us understand there's 4 here and there's 2 as a coefficient. 2 times 4 will give us 8. So 8 atoms of carbon. This other side only has 1 atom of carbon. So to balance them, it means we are going to introduce an 8 here. So let's rewrite it. It's going to be 2C4H10 plus O2. We get 8CO2 plus H2O. After we are done balancing the carbon, the next step we need to balance our hydrogen. Balancing the hydrogen, again we check the left hand side, there's more hydrogen atoms, which means we should count 10 times 2 is going to give us 20 atoms of hydrogen. So 20 atoms of hydrogen, let's check on the other side. On the other side, we have only 2 atoms of hydrogen, which means these 20, when we divide by 2, when we take 20 divided by 2, it's going to give us 10. So that means we should introduce a 10 on our hydrogen. So let's rewrite 2C4H10 plus O2. We get 8CO2 plus 10H2O. This is, we've balanced our hydrogen, which means the last atom to balance is going to be oxygen atoms. Let us balance our oxygen atoms, but you can see from here that it is the right hand side which has more oxygen atoms than the left hand side. So let us count them. There's 8 times 2, we get 16, plus there's 10 times 1, we get plus 10. So 2 times 8, it gives us 16. This is 1 already, times 10, it gives us 10. When we add them together, it's going to give us 26. So having 26 atoms on the right hand side and having 2 atoms of oxygen on the left hand side, it means that to know which coefficient we're going to put here, we're going to divide those 26 atoms on the right hand side. Let's divide them by these 2 and dividing them by 2, it gives us 13, which means the coefficient we should put here is 13. So finally, let's balance this one. 2C4H10 plus 13O2, we get 8CO2 plus 10H2O. So it means we have balanced the reaction of butane when it burns in air. So when butane burns in air, this is a balanced equation that we have at the end of the day. Atoms on the left hand side and atoms on the right hand side, they are now the same. So thank you for watching our videos. So just keep on subscribing and keep on watching out for more videos as we shall post them. Thank you.